So it's working.
It's working. Yay! It did not work earlier. Okay. Excellent. Okay, y'all been living right. That's one.
There were problems with the blue jeans earlier. The server.
Oh.
Communications.
How? I mean, not with me, was there?
No. With the other Amazon classes.
Oh. Hi, Eric.
Hi.
Did other people come in, other students come in here for class, or have they just been?
No, at other schools.
Oh, I'm sorry. Okay.
Yeah. No. Good.
Hi, Nick.
Hey, how are you doing?
Good.
All right. Yeah. Thanks. Yeah, I think so. You want to turn the light on? Or
Yeah, probably a good idea, actually. I wondered why it felt so dark.
How are you guys? Good?
Yep, doing all right.
That doesn't sound so good.
It's just now I've heard back from colleges everywhere, so it's like, all right, let's now advance quickly to May 1st.
Oh, well, that's so. What's the can you tell me any news?
Yeah, sure. So I was accepted at Rensselaer Polytechnic, University of Rochester, and NYU, and was priority waitlisted, which is apparently a new thing, at Carnegie Mellon, and was also waitlisted at Vandy across the street. So good overall.
You were
Definitely.
waitlisted to Vanderbilt? Yeah, Vanderbilt's they're getting really tough.
They are. Apparently this year, for some reason, I was talking with the college counselor just now, just a ton of people got waitlisted this year. It's a weird year. And I guess they really all are, but for some reason they're saying, yeah, a lot more waitlists we're hearing about a lot more waitlists, there we go, than usual. So, oh well. In at 3 places, they're all really good places, so not complaining.
Oh. Well, I'm sorry.
It's still fine. Like in Rensselaer, or Rochester, or NYU, they're all all have really good programs still. Not very, very best, but way up there. So.
Now, Eric, are you gonna go to not Smith? No, what?
Williams.
Williams. Is that where you're going? Can you turn the thing louder? It's hard to hear you. A little bit loud. I mean, it's a little hard to hear you.
Yeah, I don't know if we can turn the mic up, but let me move the actual thing closer to us if it'll reach. Yeah, without breaking it, like almost like that.
It seems like you should be able to turn up the wrist.
Yeah, it seems like you would, but yeah. Come on. Okay, let me. Yeah, I moved the life-size thing a little bit closer. Does that help?
Yeah, thank you.
Okay. Try speaking now.
Can you speak now?
Yeah, better.
Oh,
Stay.
Yeah, that's great. Thank you.
Cool.
More than great. I forgot to finish something. Gotta download this. Hi, Samir. How are you? How come you're not in class? You have the day off? I can't hear you, Samir. I still can't hear you. Samir?
And then see a tank.
Let's see what?
My tank.
Hi, guys.
Is it the same one again?
Can I see your faces? You guys from
Yeah, sorry.
This is my tank. I built a Halo tank.
Your tank, okay.
Built it out of scrap in like 7 hours.
You what?
Built it out of just scrap Legos I had lying around in like 7 hours. Like 9:30 to 5.
Wow.
Yeah, this is what happens when you play Halo all weekend and can't sleep Sunday night.
Oh, okay. I assume Laurel's not here.
Yeah, I haven't seen her today, but I haven't really been at school, so.
You haven't been at school?
Oh, no, I've been at an environmental competition, so we just got back.
Oh. What's the contest? Like, save the world or? No, I don't know.
It's like Quiz Bowl, but for the environment, and we have 4 topics and a current issue, so.
Uh-huh. Okay. Hi.
Hello.
There's no quiz, and hi guys, and I'm having trouble. Well, it should come. So all right. Yeah, no quiz, and I forgot my notes. I forgot my book, but I think I'll be okay. I've done this before. Some wing it, and I forgot. I don't know why, but I forgot to finish putting everything in my OneNote. So give me like 2 minutes, okay, and I'll finish. Holy cow. Was it your rabbit that was sick?
Yeah, my two rabbits. So I have two pairs of rabbits, but they don't like each other. And then the bigger pair got in with the little pair, and they like beat them up really bad. So I had to take them to the vet to get stitches and stuff.
Oh wow, that doesn't sound very good. So
Yeah, so it was a little bit of a rabbit emergency.
rabbit emergency. So Mason, when will you have the homework?
I should have it in by tomorrow. I might have it in by today, but I'm just having some trouble with it. And my dad's actually out of town, and he has stuff at home, and he's also our tech director here, and he's out of town. So, but he gets back tonight, so I might have it in by tonight, but I will definitely have it in by tomorrow.
Can you take a picture of it and scan it in using your smartphone, or?
No, we already tried that.
Okay.
Were you able to read my second set of pictures?
Yeah, that's fine. So, all right. So how are we? Okay.
Did you get my second set of pictures? Were you able to read?
Yes. Yes, I got it.
Okay, the scanner should be up and running next week, is what they said.
Okay. All right. So let's start review a little bit with these SKUTs, okay? And I'm sorry for the different. It's the same SKUT, but like just different colors, and because I tried to do it the normal background and color, but it just didn't come out very well, so it was really hard to see. So first of all, just quickly review. You see two graphs there. Ignore this yellow thing right now. Ignore that. You have two graphs. Right-hand graph, it's a graph of what? Well, first of all, altitude is the y-axis, and the x-axis is temperature. So on the right-hand graph, what do we have?
That's
this graph.
Temperature graph.
Temperature, and then the left-hand graph?
Dew point temperature.
Dew point temperature. Who said that? Okay, thank you, Mason. Okay, so let's try to now they've made it simple for us because this yellow line is basically the temperature of a parcel with respect to altitude or pressure. Okay, remember I hinted at that last time, so we don't actually have to go through that whole procedure like we did before. All right, so basically we're going to lift the parcel at the ground. We're going to assume the parcel has the same temperature as the atmosphere. Yes, Mary?
I'm sorry, can I just step out for a sec? My tech teacher walked out and my computer's not working and I can't see what you're writing. So, okay, thank you.
Yes, that's important. So basically what we're going to do is, and I guess I'll use red here, okay? I'll use a red line if I can get this to work. Why isn't OneNote not responding? So basically we follow the yellow line, all right? Like follow the yellow brick road. And so I'm lifting the parcel up along, and this what's wrong with my OneNote? Okay. And this path is the temperature as a function of altitude or pressure. Okay. Why isn't it not working? And if you notice, it's parallel to the green lines. Those green lines are dry adiabats. Can you see this okay? And so it means it's going up dry adiabatically. It's cooling at a rate of 10 degrees C per kilometer. But now notice how the slope of that yellow line changes. Okay? So now what's happening? It's not cooling as fast as before. So what's happening? Why is it not cooling as fast, as quickly as it was before? Somebody from besides the usuals. It's no longer cooling dry adiabatically, but it's cooling moist adiabatically, which is parallel to those blue dash lines that you see. But I'm going to make it red here. So why, Britt?
Oh, am I not a regular anymore? Is it because it picked up more water vapor?
Well, it's the relative humidity is 100%, and now it's not cooling as fast.
Yeah, because
right. And
isn't it
so
making like a cloud right now?
yeah, so tell me guys, tell me what the level of free convection is. Or is there a level of free convection and why? Defend your answer. Somebody from Fort Worth besides Mason. Besides Mason.
Oh, okay.
Yes.
What is
Wait,
the
what was the
level of
question?
is there a level of free convection on this graph?
Yes.
How do you define the level of free convection?
That's one of the.
I don't know. It's really hard to see on our thing.
Okay, I'm sorry. I asked, can everyone see this? And then a few people said yes, but I didn't get any other, I didn't get any other answer. So is this better or worse?
That's better.
That's better.
Thank you.
Okay. What is a level of free convection? So if you can't see, let me know, okay? What is the level of free convection?
Wait, I have it in my notes.
That's the point when the parcel finally becomes what? Warmer than its surroundings, right? I'm paraphrasing from the book. After lifting it dry adiabatically and then moist adiabatically. Is there any point here where the parcel is warmer than its surroundings?
Yes.
Okay, let's look at 550 millibars right here. Okay, what's the temperature of the atmosphere, the surrounding atmosphere at 550 millibars?
0.
0.
You go
0.
down -10, right? You go down these blue lines. It's a skew T diagram. Does that make sense?
Yes.
What's the temperature then of the corresponding parcel at the same pressure level? I realize I made that line really thick, so
30
what is it
degrees.
about? What's that?
30.
20.
-20. You go down this. If you said -30, that's like the dew point temperature.
You're going off the
other
wrong.
way. Okay.
Is that clear or no?
I think it's hard to see the blue lines just against the background.
Yeah, I realize that. It's just when I did it the other way, the contrast was really bad. Really bad. So is there any time where the parcel is going to be warmer than its surroundings? No, it's colder. So there's not going to be any convection, thunderstorms. You rely on the air to be buoyant, which means it's less dense than its surroundings. You rely on the air to be like hot air balloons. Okay? So let's try this then. So again, basically you follow the yellow line. Okay, and we start right here's part of the yellow line, even though I just made it red. So tell me, is is there what the level of free convection is, if there is any level of free convection. It's the point where it's the altitude or pressure level where the parcel just starts to become warmer than its surroundings. Yes, Taft.
Is the yellow line the dashed line?
This line right here.
Okay, I got you.
Oh my gosh.
That's the path that the parcel. That's the graph of the temperature of the parcel versus altitude. And then here's the environmental temperature graph, and here's the dew point temperature graph. So,
Okay.
where's the level of free convection approximately?
5.
Michael, where's the level of free convection?
Oh.
It'd be like every 50 years.
I'd say the right.
That's not an level of give me like a pressure level, not right or left. How about, isn't it this point where it's like just the same temperature, the parcel is the same temperature as the environment, and then thereafter, isn't it the temperature of the parcel warmer than the environment? So what level of free convection, we talked about this last time, it's a pressure level, Michael, not right or left, up or down. So there is convection. Okay, and if I asked you on a test to draw all the positive area, what do I mean by positive area? That
Isn't it?
it's where the parcel is always warmer than its surroundings. Okay, that's quite a bit of that's pretty good positive area. And what that means is the parcel for a long time throughout the atmosphere is warmer than its surroundings. Okay, see, it's again here, the parcel temperature is warmer than its surroundings, which means it's like hot air balloons, it's going to accelerate upwards. The greater the positive area, the greater the speeds of these parcels. You can get in severe thunderstorms, these parcels can have speeds of 100 miles an hour. Okay, it's almost like a vacuum cleaner. It's just sucking up things. Okay, that's pretty impressive. Okay, normal vertical speeds in the atmosphere, we're talking about a centimeter per second, maybe, like a few feet per hour. I mean, really gentle. Okay, so this was Fort Worth last night, 0Z, April 2nd, which is what time, Fort Worth?
It's
6 p.m.
8 p.m. because
you subtract 4 hours.
It's 8 p.m.
No, you subtract 5 hours for you, so it's 7 p.m.
I thought it was 4 because it's daylight saving.
It's 4 for Eastern time.
Okay.
It's 4 for Eastern time. So Mary, did you get everything fixed, your computer? Okay, all right. Yeah. So you actually did have some thunderstorms in the area. I'm not saying Fort Worth exactly, but didn't you get some thunderstorms in the area last night?
Around 6 o'clock.
Really bad.
There was some high winds and strong and large hail. Okay.
Uh-oh.
Oh no.
There goes
Samir, what happened? So here is the National Weather Service forecast in Dallas. Okay, they have a little graphic. They're saying isolated severe storms possible by late this afternoon. This afternoon. Okay. And that's because what they have is, they call this a dry line. Okay, what's a dry line? I might have talked about it. It definitely was in a homework assignment a while ago. I think when we were doing the section on moisture. Michael, do you have any idea remember what a dry line is?
I remember right. That's the line where you get a lot of hot, dry temperatures. It kind of separates.
Yeah, it's basically a boundary between a very hot, moist air and hot, dry air. So there's no temperature difference. There's a difference in dew point temperature. So let's try to find this dry line. This is, today, 18Z, you subtract 5 hours, that's 1 p.m. Central Time, okay? It's been a while since we've looked at station models, but can you see the dry line? I'm going to actually draw some isodrosotherms. That's a mouthful. That's a line of constant dew point temperature. I'm going to do it quickly. It may not be pretty, but I'm going to do it quickly. So 70 and 60. Let me draw 60. There's 60, there's 50. I'll do 60. So I blew it already here, but 50, 40. I blew it a little bit. 30. I see 30, something like this. I didn't do a very good job, but it's really quick. Okay. And just like fronts are found on the warm side of a region of strong temperature gradients, dry lines are found on the moist side of a region of strong dew point temperature gradients. Where's the region of strong temperature gradients? Obviously here. Where's the moist side? Here or here? The first one, right? So I'm going to put my dry line, I'm going to use yellow. Something like here. Ooh, yellow did not come out well at all. Purple. Ooh, can you see that? Yeah, a little bit. It's not great. Something like that. There's the dry line. What are the winds like east of the dry line? Yes, Eric.
No, actually not that stronger, but they're southerly.
Southerly. And notice, where's the air coming from? From the Gulf of Mexico, right? So hot, moist air. What are the winds like to the west of the dry line? Southwesterly. Where are the winds coming from? From Mexico. Hot, dry air. Okay, and this dry line is just like a front. If we do a side view, oops, I better get rid of this. Here's a side view. Okay, here's the hot, moist air. Here's the hot, dry air. And there's a boundary. This is a side view. And this was one of the homework problems a long time ago. Which is denser, hot, moist air or hot, dry air, even though it's counterintuitive? People think moisture air is denser. It's actually less dense. So when this hot, dry air moves into the hot, moist air, which one's going to win? This is less dense. This is more dense. Okay, and so it's going to lift this hot, moist air up, and you're going to get showers and thunder showers. Okay, so that's why they're calling for this really chance. What's the other ingredient for severe weather? Not only must the atmosphere be unstable, what's the other ingredient? I'm going to ask Victoria. What's the other ingredient for severe weather? It can't. It's not just an unstable atmosphere. What's the other ingredient?
Surface temperature, maybe?
What's it? Well, we talked about it yesterday. 2 days ago. It has to be strong vertical wind shear. What does that mean? What is strong? Well, first of all, what does wind shear mean? Change in wind speed over a given direction. What does vertical wind shear mean? Change in wind speed and direction in the vertical with respect to the vertical, right? So strong vertical wind shear, and this is just review, means there is a large change in wind speed and direction, but I'm going to concentrate on the speed in the vertical. The reason why you guys in Dallas, I mean, I'm glad for you. You're probably not going to get too bad of severe weather. There's not enough vertical wind shear. And notice, do you see anything on this skew-T diagram that could possibly give you any indication of the vertical wind shear? How the wind speed and direction's changing with height. Mary.
On the right-hand side, you can see the little flags that tell you the wind speed as you go up in the atmosphere.
Absolutely. In other words, bad color contrast again. Black on black, that doesn't work. There we go. This gives us the horizontal wind speed and direction, just like the normal station model, but at various levels. And here's the problem. It's hard to see, but the wind speed, here, I'm going to guess it's like maybe 20 knots, which is about 20 miles an hour. And what's the wind speed here at 300 millibars? About 45 knots. Not a lot of wind speed, vertical wind shear. Some. Okay, but I think that's why, fortunately, they're only calling for a very small very slight chance in severe weather. Okay, questions? How about this? This is the outlook from the Storm Prediction Center. This is for I'm sorry, valid 3. This is for tomorrow, 12Z, to Saturday, 12Z. So what? Like 6 for us Eastern time, 8 a.m. to 8 a.m. to 8 a.m. the following day. And they're saying, do you see any bullseyes as far as they're giving you predictions of, what are the chances of severe weather? Any of you guys in this bullseye? Is that where Jackson is? And I don't know, is Nashville like right here or something like that? Okay, so this is for Friday morning to Saturday morning. So let's look at, again, I'll try to do better on the color contrast, but this is Jackson. This is a forecasted. Okay, it's not the actual, it's forecasted. It's valid 0Z on Saturday. Okay, again, we don't have to go through all those steps. You just sort of follow that yellow line. Although, again, the yellow line actually, and it's not yellow here, the way I drew it, it starts here. So can you see, is there lots of positive area? Oh yeah, lots. Okay. The greater the positive area, the greater the speeds of these updrafts and the thunderstorms. Is there strong vertical wind shear predicted? This is easier to see. They don't put so many wind things there. What's the wind speed at the ground? Mary.
Is that about 10 knots?
Yeah, 10 miles an hour. What's the wind speed, at 350 millibars? 60 knots. That's pretty good. Okay, that's a pretty good vertical wind shear. So they're not saying it's not enough for tornadoes, but for severe, here's their outlook. They have categories, marginal, slight, enhanced, moderate, and high chance for severe weather. So you're sort of in the enhanced region. Okay. So I wouldn't write your wills yet or anything like that. So, okay. So the reading, all right, this is sort of review, but what was the reading? They talked about single cell thunderstorms. Why don't they last very long? This was review from Tuesday. Yes, Eric.
So there's this thing called the outflow. Well, 2 reasons. One, because of the lack of strong vertical wind shear, the downdraft is in basically the same place as the updraft. The precipitation doesn't move very much in relation to the updraft, so the updraft falls apart pretty quickly, and then the thunderstorm just stops.
Yeah, this is a side view. These arrows, which have the same length, indicates the wind speed isn't changing with height. So the updraft forms, it's not tilted, but then when it starts raining, the downdraft basically forms where the updraft is and kills it. Okay, there's a second reason, and it's this, okay, and it's hard to explain why, but when you have weak vertical wind shear, the gust front outruns the thunderstorm. In other words, through time, you have the thunderstorm lagging way behind where the outflow boundary is. Remember that outflow boundary is where the cold, rain-cooled air meets the environmental warm air. And what happens when that cold air barrels into the warm air? What does it do to the warm air? It lifts it up, causing clouds and precipitation. And this is where new thunderstorms can form. But the problem is, so basically you have new updrafts forming right here because it's that warm air is being lifted by the outflow boundary. But that you want the updraft to be where the thunderstorm is. This updraft is way away from the thunderstorm. So this thunderstorm dies because it has no supply of air that's rising. When you have strong vertical wind shear, and again, it's sort of hard to explain why, you get the tilted thunderstorm. But more importantly, that outflow boundary basically does not go very far ahead of the thunderstorm. And so you have this updraft air right where the thunderstorm is, and it's basically supplying, you want these updrafts to form where the thunderstorm is, because the updraft is what keeps the thunderstorm alive, because that air, as it rises, it cools, causing clouds and precipitation. Okay? So multi-cell thunderstorms are basically thunderstorms that merge together. And they survive, and I'm not going to go into great detail, they survive because you have strong vertical wind shear. All right? But what is the prize of thunderstorms? There's single cell, multi-cell, and what?
Supercell.
Supercell. What makes a supercell different than all the multi-cell or even single cell? What makes it super? The updraft rotates. The thunderstorm rotates. So here's why. And I'm going to use my pencil as an example. But here's the ground. This is a side view. These arrows represents the wind speed with height. And so I'm going to take my hand and put my pencil here. And my bottom hand represents the air at the ground. I'm going to assume the air right at the ground is at rest. Okay? And now I'm going to move my top hand over my bottom hand. And my top hand represents the airspeed, like a few hundred meters or half a mile above. And by moving this over, because the air above is moving fast, what happens to the pencil? It's hard to see, but I can get the pencil to start rotating. Okay, do you see that? And so, as a matter of fact, because you have this vertical wind shear, the air is spinning. But the problem is, it's spinning in the wrong direction. In other words, the axis of rotation is horizontal. Let me give you another viewpoint. I'm changing the viewpoint. It's still at the ground. But here's my tube of spinning air. So I'll have it spinning like this. Oops, what happened? Here's my tube of spinning air. Gosh, I can't draw. Here's my tube of spinning air. It's spinning like this. So here's my axis of rotation. Okay. Here's my axis of rotation. But what's the axis of rotation in a spinning updraft?
Horizontally.
Yeah, when an updraft is spinning, here's the ground, it's spinning like this as the air rises. And so here is my axis of rotation for a spinning updraft. All right. So how do I get the air to go from a horizontal axis of rotation to a vertical axis of rotation? What's the key? Michael, do you have any ideas? I'm trying to get you involved more. That's why I'm asking you.
I don't have any good ideas. I don't have any good ideas for this.
It doesn't have to be good. Do you have any ideas, period?
Mm-mm.
What's the key? What's the key? So basically, here's that air that's spinning horizontally, horizontal axis of rotation. And then, so again, it's like this. Oops, what happened? Oh, shoot. I want that to go away. But all of a sudden, this updraft comes along in the thunderstorm, and it takes some of that horizontally spinning air and now makes it spin along a vertical axis. Does that make sense? Or another way of looking at it, here's my horizontally spinning air. Horizontal, I mean the axis of rotation. And then there's an updraft in the thunderstorm that takes this air and now reorients it, so now its axis of rotation is vertical. Okay, and that's what this picture's trying to show. And they had a picture of it in the book. Remember that? Yes, Samir, did you have a question? Samir, I still can't hear you for some reason. Nope. I'm sorry, I can't hear you. I don't can mail you later. Okay, that I can understand. Okay. Does that make sense? So the updraft, as it takes some of this horizontal spinning air and makes it vertical. And so the updraft starts rotating itself. I'm going to have you quickly, because there's a delay when I try to show it to you on the screen so quickly. I don't want to take too long. And we've seen this a little bit earlier. Okay, I am now going to send all of you. Again, you can always share, all right? I gave you 3 links to YouTube videos, or 2 links, I guess. Should be sending any time now. I will try to show you a better video of it. I didn't have time to get it going. Okay, I sent it all to you, and try looking at the first YouTube link that I emailed to you. This is a picture of a supercell, and it's a video, okay? I mean, we can try it, but if not, then you're going to have to actually download it, okay? See, I don't know if it works. There's a delay, and it's not really smooth. But can you see? Well, I guess it's not too bad, actually. Can you see the rotation of the updraft? Yeah, maybe you don't even need to download it. Okay, look at that updraft. I mean, that whole updraft is spinning. And that is a supercell. And these supercells are the ones that produce the most ferocious tornadoes. All right. Unfortunately, it's quite unfortunate, but well, I guess it's not unfortunate. Never mind. I don't know why I said that. Tornado watches. Sorry, let me get out of this. Tornado watch. The National Weather Service issues a tornado watch. A tornado watch is issued.
Mr. Chang.
Yes, you can't see. Yes. Let me get that going. Thank you. Let me... So a tornado watch is issued when the atmosphere is conducive. Sorry, that may not be the spelling for conducive. For the formation of supercells. Because supercells are the ones that produce the majority of tornadoes. Okay? So, and what are the conditions? 1, you need a moist, unstable atmosphere. And 2, you need strong vertical wind shear, but not just speed wind shear. You need strong, not only speed, but directional wind shear. where the direction of the wind is changing with height. And it basically gives the atmosphere more spin, okay, by having a change in wind direction with height. All right. Last thing, because I want to show you this other video that you may have to download. Microbursts. What is a downburst? I was going to give a quiz on this, so you tell me. What do I mean by a downburst? This is in the reading. Mary.
A downburst is like a small downdraft of air that when it hits the surface of the earth, it spreads out really quickly and it can cause a lot of damage because the wind speeds are so high.
Yeah, it's an intense downdraft. And there's various kinds of downbursts. There's macroburst. Oh my gosh, macroburst and microbursts. Remember that from the reading? And what's the distinction between a macroburst and microburst? First of all, its size, the diameter of the downburst. Okay, microburst is smaller than a macroburst. And I think macrobursts can last longer. Okay, I'm not saying it makes a homeowner feel better, but a lot of times when there's a thunderstorm and your house, some homeowner's house or a farmer's barn gets damaged, they always say, "Oh, it's due to a tornado." Well, not that it makes them feel better, but a lot of times it's actually due to these downbursts, macrobursts or microbursts. Okay, again, not that like, oh my gosh, thank goodness my house is destroyed by a microburst. And so in order to tell whether it's a tornado or a microburst, they have to do a field survey. They'll go up in a plane or a helicopter and look at the damage. And if they see signs of rotation in the damage, what do you think? They're going to say, oh, it's probably a tornado. If they see this, I'm looking from above. If they see trees, these are trees that have fallen to the ground. I'm looking from above. I'm simplifying this. I can't draw trees, but if they see some point where it's like the air hit the ground and then spread out horizontally in all directions, then they can say that must be a downburst, huh? Does that make sense? So again, but some of them, it can be really intense. And that's what I need you to actually, why don't you down or link to the second YouTube video that I showed on the, it's like a 7-minute thing, and I want it needs to be a smooth video rather than choppy like it'll be. So can you do that, the second one? I don't know what's wrong. I did send it all to you, so mine's not working. Well, there it is, I guess. But I don't know why it's not working. Can you play this video?
Yeah.
I'm not able to play it for some reason. No, that's not it. Oh, here it is. Here it is. Oh. It's the second one. This is of a downburst. I don't know if it's a microburst or a macroburst. That looks like neither. Oh, that's an ad. An hour, 1 minute 47-second ad. Oh, that's great. Oh, I'm gonna skip the ad definitely.
Soldiers' physical injuries are well known to the public, but much less familiar.
I think in theatre, a lot of things can trigger
I
certain
don't know
emotions
why.
and quite acute stress reactions. And when people are away from an environment, away from the people they trust to manage how they usually feel.
Okay, I don't know. It was playing other things, and I mean, you can look at yours or mine. It's going to be choppy if you look at through mine. It's already choppy as is. This we haven't gotten to the downburst yet. You'll know, and I'm sure you. Well, hopefully it hasn't occurred too many times at your house. You may not have a house too long. This is not it. We had it working. We did the cable connection, well, but then I don't know. We couldn't see the whole horizontal part of the picture. Remember that was the problem. I don't know.
Really? It looks better for you. It would not
Oh, really? Trust me, this is not the down. You'll know. The anticipation's killing me. Oh, I see the rain coming. And that rain shaft that's dragging the air down, right? Oh my gosh, now Armageddon's here. Or it's getting here. It's still not it. Oh, experienced a downburst like this, or to some degree? I mean, I have not to that extent, but it's somewhat impressive. So I don't know.
My job is fixing people's celebrity clientele mostly. They have needs, I solve problems.
That's nice. How many of you seen a tornado? No, yeah. Yeah, I mean,
We've seen tornadoes.
Oh yeah, we've seen naders all
I'm
the
not.
time.
I mean, Fort Worth definitely, and Mississippi. This is your time. Early April. April's the time for you guys to have tornadoes. Okay. So, all right. I guess that's it. You have an assignment on Tuesday. They're going to talk more about the spin of the atmosphere. It's called vorticity. It is tough. I mean, conceptually, I'll go over it, but I do want you to read it, okay? I want you to see things twice, reading and then going over, okay? There is homework, too, all right? Please do not wait till the last minute. So happy to help you, though, okay?
Here comes the gush.
All right. See you later. And yes, and Mary, have a good time.
Thank you. I'll just email Miss O'Bear.
I hope it's raining the whole time.
No.
No, I'm just kidding.
I'll email Miss O'Bear and have her send me the recordings.
All right.
Thank you.
Hope you get. Oh. So it would have been better on their end, right? If we had hooked up the cable. I don't think. Well, I didn't do too bad considering I didn't bring my notes.
No, I think that's probably the best way to go about it is send them a link and say you watch it where you are.
Yeah.
Because I mean,
yeah.
The problem is that you're like trying to transmit something that's supposed to be smooth and everything over the internet to all these different places at the same time. Now you transmit your signal to that box, and then it transmits it to Blue Jeans, and then Blue Jeans transmits it to them.
Yeah.
So if you get a really good connection between you and this box, it's still going to degrade on the web.
Yeah. So that
we
I
had
did
the
start thinking.
music history person who kept putting up YouTubes of music performance, and it's horrible because it's choppy and the sound is off, and if it gets a little quieter, like the sound cuts off completely and then it pops back on when it gets a little louder.
Has he got the idea to do like what I did? Or?
No, he keeps trying to like show it on here. And it's like